Hi all, welcome back. Today we will talk about the storage options in GCP, and out of that we'll look at the Google Cloud Storage. So let's get started with various storage options. So the first one is block storage. We have already discussed what block storage is and about various types of disks available in GCP to use. So they are persistent disks and non-persistent disks like HDDs and solid state drives. So the next one is to store immutable blobs like videos, images and files. So for this type of storage we can opt for a Google Cloud Storage. So we will discuss more about this in a while. So the next type we can store is OLTP, which is online transactional processing. So here data is stored in the form of tables or relations. So this is a relational database system. So for this type of data, for relational database, we have Cloud SQL and Cloud Spanner in Google Cloud Platform. So we have Cloud SQL, which is an open source, which is same as similar to MySQL or PostgreSQL. And Cloud Spanner is Google's proprietary tool used for relational database. Next type is for NoSQL database. So for NoSQL, we have data store and big table here. So data store is for document storage and big table is for fast sequential scanning, which is a columnar database. So for OLAP or OLAP is online analytical processing. So we have a good tool which is BigQuery. BigQuery can store huge amounts of data and have a SQL interface for giving SQL commands and to retrieve data from that. So this is Google's data warehouse solution. So now I will let you know what Google Cloud Storage is. Google Cloud Storage is a solution for storing immutable or unchangeable data like videos, images, files, etc. We can store almost infinite data in it. It is much cheaper than almost any other type of storage in Google Cloud Platform. So the basic mechanism in Google Cloud Storage is to create buckets and store data inside the buckets. So buckets are globally unique. Data is encrypted when stored in bucket and buckets are standalone. This means if we create a bucket and store data produced by a VM into that bucket, once if we delete or stop that virtual machine, bucket is standalone, it won't delete this. So for bucket, you do not have to have any instances running, so it is completely independent. The things that are stored in the buckets are called objects. So buckets can be based on location and storage classes. So based on bucket storage classes, we have four types of buckets. One is multi-regional buckets and the second one is regional buckets and the third one is nearline, fourth one is Coldline. These can be used based on our requirements. So let's talk about multi-regional buckets. So for multi-regional buckets, Google promises 99.95% of availability. This is huge. Since this is multi-regional, this is called as geo-redundant. That means the data can be accessed from anywhere in the world. Practically, data is stored at least in two regions which are separated by at least 100 miles. So we have data redundancy here. These multi-regional buckets are used to store for frequently accessed data. Whenever we want the data to be frequently accessed, these are the best type of buckets to use. A bit costlier when compared to others because they are available in multi-region. So the next one is regional buckets. So Google promises here 99.9% availability for regional buckets. Some 0.05 less than multi-regional buckets. So this means objects stored here are region specific. These are also used for frequently accessed data. So the next one is nearline buckets. Google promises here 99% availability. But the condition is we need to store data for at least 30 days in this case. These are very low at cost, used for infrequently accessed data. For example, data backups and archival storage. Because for data backup, when data is backed up and when data is archived, we will use that data very less frequently. So that's why we can use nearline buckets for this type of data. So the minimum storage is for 30 days. So let's discuss on Coldline storage buckets. So Google promises here again 99% availability of data. So condition is here we need to store data for at least 90 days. So 3 months duration. So this is best suitable for legal or regulatory data. So the data which can be accessed once a year or once in 2 years or twice in a year like that. So we are accessing data very less frequently. So this is the cheapest of all buckets. So for all classes, this is much cheaper. So what happens if we store infrequently accessed data into, for example, multi-regional or regional buckets in which frequently accessed data is stored? So simple, we will be ending up with a huge bill. This is because storage costs are less for nearline and coldline buckets, where we can access data infrequently from these type of buckets. So that's it, guys. This is a small session. We will see how to implement buckets in GCP and perform various operations in the next video. Thanks. Please subscribe to our channel for more videos. Thank you.